Hi, good morning, everybody. Welcome to yet another episode of Health Discourse with Sakshi and Sushant. Good morning, Sushant. And today we are going to be discussing about healthcare data collection models, right? So, as you know, in the market, you have a lot of variables and diagnostic tests and whatnot apps and lot of things going on, right? But today we are going to talk about what is the relevance of such data collected and is it helpful for the patients, and is it being used for any specific purpose by these companies, or is it just sitting there in someone's server, right? So Sushant, my first question to you is that that the current set of healthcare data collection models, variables, and all these things have helped collect, analyze a lot of healthcare delivery data and a plasma level data, obviously, through the diagnostics. Now, we know that one has been tracking blood sugar level, RHR, sleep pattern, cholesterol levels, VO2 max, then you're counting steps and then calories. But still, why 41 million people they're dying of chronic diseases every year? And with these stats such as they're really scary because 100 million Indians are diabetic and 13% of Indians are at high risk of cancer, chronic kidney disease, non-alcoholic fatty liver disease, which are detected at later stage, and the list goes on. So exactly are we missing here?
Okay, so we have to first understand, uh, if you see 5 years, 7 years back, we never had technology to understand deep down what is going on inside our body at a cellular level and molecular level, right? But I'll come to it a bit later. So whatever data points you're collecting, it's as you rightly pointed out, it's healthcare delivery data of point of care diagnostics, which is, in simple words, a post-mortem or executive summary of what has happened inside your body, right? So essentially, when you are eating something, there are billions of microbes living in our mouth, right? Uh, Pre-processing the food, then a lot of these foods, some of these foods are metabolized in the small intestine by human body. A lot of it goes to colon, and a lot of these microbes living in a large intestine, metabolize these foods and convert into certain byproducts. These byproducts are something which gives us nutrients or toxins, right? We stimulate immune system. Uh, it triggers a lot of inflammatory reactions, and these inflammatory byproducts are released in the bloodstream, and this is what we track, right? So essentially, there are 100 billion microbes in our mouth, 30 trillion microbes in our gut, right? Expressing more than 2 million genes, right? And 30,000 plus food molecules, each microbe performing more than 3,000 of chemical reactions, right? So it's such a millions and billions of data sets and trillions of data sets, right? Which culminate into one or two or three or five or 10 biomarkers, right? Now it
So,
doesn't.
so what is happening with this data? Is it just sitting on somebody's server, or are they are doing some like they say that we are doing artificial intelligence, machine learning, we are building this, we are building that. So, is it exactly happening, or is it just a bubble that they have created around themselves?
See, that is something these companies have to answer. But frankly, AI ML have been used by companies as jargons, as the selling points, right? These are systems, right, made by us, or these are technologies. For these technologies to give some output, it has to be right inputs, right? So whatever data points, whether it is using blood sugar levels using CGMs, or blood test APOB 100, which is again an indication of cholesterol, or resting heart rate, or VO2 max, or sleep pattern, or whatever it is, right? These data, if you churn inside the AML model, what does it tell? So it tells, okay, your APOB, or probably if you do also a trend analysis, they'll tell, okay, this particular age group, this particular symptom, this particular conditions have overexpression of APOB 100. But how do you know what is causing it? So the question is, why I have this, elevation of this biomarker, right? I know this is bad, right? I know this is bad. Then what I have to do about it, right? I don't know, because these are these are standard or fad interventions. So if I have an APOB 100, probably will say stop eating eggs, right? Or probably suppress your cholesterol, have cholesterol-free diets, have a lot of drugs to suppress it. So there are multiple things, right, which actually doesn't go deep down to the root cause, right? So when we are collecting data from CGMs, from wearables, right, tracking blood sugar level, tracking ApoB 100 through point of care diagnostics, right? These are not going decoding the pathogenic process involved in onset and progression of diseases. These do not go down to the deep level, molecular level, what is happening. For instance, could these tell, okay, if I have an IBD flare, right? Uh, which specific genes are being expressed, which microbe is expressing that gene, right? Or which microbe is producing, for instance, sulfide, which is causing inflammatory, how immune system are reacting to it, right? What our endothelial cells are doing, why I have food intolerances. So these are the questions these data points do not answer, and we need to ask the right questions. So when you ask these questions, these data points will not be able to answer this. And the most important thing, 99% of our biology is driven by genes expressed by a microbiome, whether it is in mouth, whether it is gut, whether it's skin, saliva, uh, vagina, scalp, everywhere, right? So these tests do not decode 99% of the biology. So if you are want to manage your disease and if you want to make doctors and healthcare system rich, probably go ahead and buy these variables. It is not going to help, right? Second thing is, all these diseases. So someone if has a high blood sugar level or HbA1c high right now, we started developing diabetes 30 years back, right? So there are a lot of molecular indications which happen with interaction between your food, your microbiome, interaction between your microbiome and your body and human body, which release certain pro-inflammatory molecules which our current set of clinical and diagnostic tests of variable cannot identify. These are asymptomatic or hard to detect. So in case of chronic kidney disease and non-alcoholic fatty liver disease, right? So CKD, we end up going for dialysis, right? And we have seen startup coming, creating dialysis centers. We were discussing this yesterday also, right? So creating dialysis centers, just trying to, clean out your kidneys every 15 days. You have to come and for dialysis. And it's a financial model. It's not a healthcare model, right? So these data points are not going to help in any way in terms of curing your disease, right? Or preventing you from disease from happening. So idea is when you have such huge technologies in place, right? Uh, what we call as artificial intelligence and machine learning. First of all, we need to feed with huge data sets, right? And we need to feed these correct, relevant data sets. We have all the science and technology in place to actually prevent the disease from happening. But for that to happen, we have to collect the right data sets, which is molecular data sets. So if we talk of healthcare delivery data sets, we have 10 to the 24 bytes of data sets, right, which is huge. But is it really solvable? Right? As you mentioned, 100 million plus people are diabetic in India, 13% have cancer. That we cannot decode, chronic kidney disease at early stage. Obesity is going haywire. So for instance, GLP-1. So there are GLP-1 drugs coming. People are saying if you're obese, start counting vegetable calories, and eat less this bullshit crap. There's nothing. If so, that is there's no science. If you eat less, you will not gain weight, right? But will you start restricting your body for your whole life, or think of whether your parents counted how much of kidney beans, how much of rice, how much of chapati, how much of bread I'm eating, how much of protein I'm eating. They never counted that. So it is all about metabolism. Metabolism is regulated by the microbiome. So again, there are a lot of these hormones and neurotransmitters they expressed by microbiome which impact your satiety level. For instance, GLP-1. Again, GLP-1 drugs you're taking, GLP-1 is produced by a microbiome, right? And so in that case, basically there are certain microbes which express certain genes which produces GLP-1. If you microbes, if there's a gut dysbiosis or if you don't have this microbe, probably you will not have GLP-1. So if you even go for a GLP-1 drug, right? GLP-1 drug effectiveness of drug will again depends upon your microbiome. I think we discussed this in an earlier talk also, right? And for instance, if you have a high APOB level, a high blood pressure, right? Let us talk about high blood pressure levels, right? How do you know? It could be caused by certain processed foods, or maybe certain wrong lifestyle choices, right? Certain wrong foods, right? Maybe a lot of fats, a lot of carbohydrates, right? Right. But what if I tell you that mouthwashes and fluoride in toothpaste could cause elevate your blood pressure? Would your these markers measuring your blood pressure, right, would really help you decode that this specific blood pressure is being due to overconsumption of mouthwash or having fluoride in your toothpaste, right? Or for instance, when you talk of chronic kidney disease, one of the biomarker is bad breath, right? So bad breath could lead to chronic kidney disease, and I think we discussed this earlier also that, or probably nitric oxide production, which is again one of the pathways is the oral microbiome. So if you have high glycemic index or sorry, high glycemic diet, if you have a high glycemic response, your blood sugar level is high, would your CGM be able to tell it is because of endothelial cell dysfunction inside your body? Or it is because of, for instance, certain proteins such as tyrosine could lead to the production of microbes could convert tyrosine into PQ-SOL. PQ-SOL could lead to oxidative, it could cause chronic kidney disease. This oxidative could impact, you know, your heart heart health as well. But it is all linked to nitric oxide. But these markers will never tell you whether what is the production of nitric oxide, right? Or VO2 max could tell what how much of nitric oxide your body is producing, right? So even the exercise performance is linked to nitric oxide. So the more nitric oxide is produced via oral microbiome, the less oxygen is used per volume, so your exercise performance improves. So there are multiple things here, right? You can't just say, okay, my VO2 max is this, my resting heart rate is this, my stress level this, I've slept less, my blood sugar level is high, so I need to eat less carbs, I need to eat more fiber. That anyways, fiber is good, but on what basis? What carbs? What proteins? What amino acids? How much you need, right? So there are multiple things. So again, ta- taking foods, personalizing food on your blood test, because if you have a high blood sugar, you'll be told to eat less carbs. It's all flawed assumptions. So, your certain proteins could also lead to insulin spike, right? You may not know, right? So just by tracking and having a low carb diet, or having high protein diet may be counterintuitive, right? And again, to understand food, if you take food is a sack of 30,000 plus molecules, right? And every time we are eating a meal, we are ingesting around 1,000 to 2,000 molecules, and these molecules. So if you see, these molecules interact with your microbiome, and produce certain byproducts. These byproducts will either give you nutrients or give you bad things, right? So essentially, 100 million microbes, 38 trillion gut microbes, 100 million oral microbes, expressing more than 200,000 genes at one point in time, 30,000 food molecules, each microbe doing 3,000 plus chemical reaction one point in time, producing tens of thousands of, metabolites and biochemical reactions. How do you, even track with these biomarkers, blood level biomarkers, that what is going on inside the body, right? So essentially, we have AI and ML technology in place to actually go deep down, collect a lot of molecular data, analyze it, what genes are being expressed, what genes are overexpressed, what genes are underexpressed, measure each of the pathways, molecular pathways, whether it is human gene expression, microbial gene expression, mitochondrial gene expression, right? And even the food ingredients, how they're interacting with these microbes, expressing different pathways, right? And then different chemical reactions. So we have all this ML and AI, which could, you know, churn all these trillions of data sets, which could actually find out, tell you, predict diseases. We can actually predict, find out whether if you're following the same thing, these are the certain pathways which are overactivated, right? So for instance, in case of diabetes, people do not consider that oxalate metabolism could cause insulin spike, which is eating spinach or beetroot or almonds, right? So probably some people would feel that awkwardness after eating almonds as well, right? But these would never show up in your CGM machines, right? Similarly, if you are eating less carbs, a lot of less carbs, or there's they're micro, they're not feeding your micro the right food, probably they would get hungry and they would go to your gut and start eating fructose. Fructose is a sugar molecule, and then again it raises your spikes your insulin levels, right? So essentially, in case of diabetes, there are multiple factors at play, right? For instance, we know it, there fructose metabolism and histamine, we know it, histamine could trigger, right? So there are multiple things, right? So just having these uh, plasma level data sets or these variables is good to manage your disease. If you want to, if you're earning money to make hospitals rich, doctors rich, well, go ahead, but
So
you need
apart
to.
from this test, I think what these days is we are seeing that there are DNA tests, then there are food allergy tests, then CGM. I mean, blood test is something that we've already spoken about, but yes, CGM is there. So
Hmm.
do these are these really effective? I mean, we have again discussed time again, CGM is something we have discussed previously in our talks, but then these food allergy tests and DNA tests. Let's just narrow this down a bit for
Okay.
other
So,
listeners.
let's break it down. So DNA, right? If we talk of DNA, we humans have around 25,000 genes, right? Which we get from our parents, right? And microbes live in a
And
robust.
I'll add one thing here because when we were studying and our team was doing the research, we also came to know that an earthworm has 33,000 genes, more than human
Yeah,
beings.
yeah.
Yes.
So,
So yes.
so microbes have code for around 2 to 20 million genes, right? So, but epigenetically, we are 99% microbial. We are 1% human, right? So when we are born, we born with one egg, there are one cell, and it multiplies, cell divides and multiplies, right? So every tissue inside our body, whether it is lung, heart, brain, all have the identical DNA, right? So DNA has the potential to become any of those, you know, tissues, but it doesn't know which tissue it becomes or what function it performs, right? So if you see, all body parts, body organ perform vastly different functions. You can't ask your heart to eat food for you. You can't ask your brain to see things, right? So and there's a reason why you have eyes on your mouth. You don't have eyes on your head or on your legs, right? So it is all about expression of genes. Certain genes are overexpressed, certain genes are underexpressed, right? So coming on to DNA, if you have to sequence your DNA for a person who is healthy and then when he is diseased, his DNA would be same. His DNA will not change,
So
right?
that also means that whatever DNA, when DNA is the same, right? When the genes, genetic data is same DNA. So that also means that whatever results and recommendations are coming up along with that DNA test is going to be the same throughout the life. It is a
Yeah.
stagnant form of a data. It's
So
static,
then,
it's not variable, right?
so people will not agree to it. They will say, no, no, DNA test is everything. It tells the risk. Obviously, it tells the risk. It tells the potential, right? Potential
No,
of developing.
but what I'm seeing these days that many DNA testing companies they're also coming up with testing for skin, DNA testing for pharmacogenomics. This which is like
This is
they are
just this
going to.
is just a way of they are not getting customers. Just a way of creating more products so that people come and creating a
But
buzz, right?
basically, if I am a customer and if I were to assume that this DNA test is going to benefit me in some ways, it will only tell me the risk, the possible risk. It may happen or may not happen. It's
So,
more like that.
two things. When your cell division is taking place, certain genes do mutate, right? And your cell machinery is smart enough to repair that DNA, but whatever it survives is leads to genetic mutation, which is less than 5% total disease, right? So any disease linked to DNA is a rare genetic disorder, and it is called rare. It is called rare genetic, but it is rare. It is not something that is not linked to lifestyle disease, right? So that's all. So you have to ask any person, if he has diabetes, and when he's healthy, when he's diabetic, do his DNA is will be same. Risk would be also the same, right? So similarly applies for microbiome also, right? So 99% of the companies focus on microbial DNA, microbial taxonomy, right? Which focus on microbial names. Oh, you have this bacteria, so you have a high risk of this, blah blah blah. For instance, P. gingivalis in the mouth, right? It is one of the bacteria which causes periodontal disease, which is also linked, which may also be linked to your type 2 diabetes, right? So it is found in 88% of the adults, but 88% of the adults do not have periodontal disease. So they always have external trigger, right? It is not DNA, it is expression of genes. So again, an external trigger, it can be your nutrition, it can be environment, it can be stress, right? Which makes a gene turn off and on. When a gene is turned on, it is copied into RNA molecule. Then RNA transforms the genes into proteins, and proteins which perform, inhibit, or activate certain functions. Right? It
Okay.
is it is what
So, so,
impacts it.
uh, so, so let me narrow this down. This is the genes, the data, whether the genes is switched on and off, it goes to the RNA, the data. I mean,
Hmm.
what are the molecular communication is happening between genes and the RNA, right?
Hmm.
Then from RNA, it expresses a certain set of proteins, and then those proteins are released in the body. That's what you're saying.
Yeah. So essentially, you see, every microbe would be expressing different genes. Some microbe would be expressing more genes, some would be less genes, some would be expressing or expressing certain genes, under expressing certain genes, right? For instance, if you have to see my uric acid production at a molecular level, right? So it would be around 500 plus microbes expressing each microbe expressing different genes. So there's a lot of data, right? That's why ML and AI comes into picture. You can build machine learning models which could actually collect all the RNA data from your biological sample, convert into gene expression data, and then blend it into various pathways. So you could actually uh, draw meaningful conclusions from more than 10,000 plus pathways and biomarkers, right? Which is a data instance, which is what we need. So we need to understand. So for instance, if I have to know Sushant would develop diabetes in next years or not, next 10 years or not, right? So if I have to sequence my RNA, my microbiome, right, gene expression of my microbiome, I could know, okay, I will, if I'm following the lifestyle, the nutrition which I'm following, after 10 years, I will develop this, right? And these things, if I have to go to a clinical test and get my blood test or use my CGM, it will never tell me because these molecular indications of signals are invisible, are asymptomatic, right? So these kind of molecular interactions happen for years before the symptoms show up. And since till the symptom doesn't show, we have nothing. So doctors say, okay, you don't have anything. Your blood works is fine, everything is fine, don't need to worry. But we wait for 10, 15, 20 years for these signals, asymptomatic or hard to treat signals to be converted to symptoms. Now we have symptoms because we have already entered the disease state, right? So whatever you are tracking through your CGMs or wearables or blood works is just the outcome of symptoms, right? So you are going to suppress those symptoms. If I have APOB 100 overexpressed, I don't know why it is. So I'm going to assume something and trying to suppress my cholesterol levels without
So this
understanding.
is this is again a hit and trial method. It is not something
Yeah.
which is definitive, or this is not something which has any
And, and,
validation in
and
terms
tell
of
me
data.
one thing. Tell me one thing. You are taking CGM. You eat a meal, right? You assume that, if I'm taking kidney beans and rice and curd, right? It is only rice is going to spike my blood sugar, so kidney beans and curd will not, right?
It
And
could be any
you
of them. It could be any
yeah.
of them.
So
So
kidney beans again, I'll tell you, kidney beans has lecithin, which can be converted certain microbes into TMA, or TMA is linked to your fat storage, your even cardiovascular disease, right? So essentially, and you don't say first I'll eat rice, then I'll eat kidney beans, then I'll eat curd. You don't do that, right? So you mix your meals. So, essentially, you need to understand how each food is going to interact with the microbiome, how each food is going to impact my insulin levels at that point in time, right? And again, CGM would not track the nitric oxide production. We discussed that,
yes, yes.
nitric oxide synthase actually have all these insulin
I
secretory
would,
summers. Mhm.
Sushant, I would also urge you to talk about nutrient absorption here. But because what happens is, as far as I know about the DNA testing, the nutrient absorption part is something that they cannot decode because that is a kind of data that is only available through genes expression, right? So, like you mentioned, that there are some microbiome companies which are saying that you're deficient in this or that, but that is only based on whether the bacteria is present in the body for a certain nutrient or not. So,
They're
nutrients
not,
such as
they're
vitamins,
not, yeah,
minerals.
they're not saying you're deficient. You're saying you have this bacteria, you do not have this bacteria, or you have less diversity of this bacteria. So you will have vitamin D or vitamin B12 deficiency. It doesn't work like this. Names doesn't work. For instance, if I have a headache and I come to you, Sakshi, I have a headache, right? So it doesn't tell anything, until unless I know that Sakshi is a doctor, right? And it could process the data which I am telling and tell me why I have a headache, right? It's the same thing. Name doesn't matter, right? Our body is a sack of biochemical reactions,
So, with
right?
the name, we are mentioning referring to the taxonomy of bacteria, that they say the taxonomy, right? That does
Yeah,
not
yeah,
matter. What matters is what functions they are performing and what
yeah.
molecules they are producing, whether it could
Yes.
be a nutrient or a toxin,
So
right?
downstream functions in terms of RNA, in terms of metabolites, right? So in terms of maybe lipids, a lot of these things, right? So essentially, you need to decode what they are processing, what they are producing, what their byproducts is. You don't do if, as I mentioned, P. gingivalis, having P. doesn't mean you have periodontal disease, right? It just tells the potential of probably you would have, right? For instance, Fusobacterium nucleatum. It is again an oral bacteria which is said to cause uh, colon cancer and IBD, right? In your mouth, right? It's in your mouth. So microbe in your mouth could cause IBD and cancer, right? But only if it is expressing virulence. If you have Fusobacterium, doesn't mean you'll have colon cancer, right? There's a potential provided if you are feeding something which makes that microbe express virulence genes, which causes certain production, causes probably metabolites, right? So all these data points are never captured. So idea is if you really want to get rid of chronic diseases or really want to have a disease-free life, you need to understand the progression of disease before and during its onset. You don't need to wait for years of when you are dealing with a disease and then you have symptoms, right?
Absolutely.
Right.
I agree.
So,
So, Sushant, I think with this, we have given a lot of insights to our listeners about what kind of data is being collected these days. And let us conclude this talk by giving some information about how Gene Fitletics is collecting their molecular data and how do we process it and what is the benefit for an end user with
okay,
us.
okay.
Yes.
So essentially, we have built India's first system biology platform. So what I term of system biology is, in a simple way, is currently everyone treats human body, every body separately. So if you have a kidney disease, they will focus on your kidney disease. If you have a diabetes, they'll focus on pancreas. If you have a heart issue, they'll focus on your heart, right? So there are different specialists for different organs, right? But our body is interconnected. So that's what we call it. It's a wholesome system biology, right? It's linked to each other. So when we talk of system biology, what we do is we use multi-omics approach, right? We collect a lot of molecular data of oral microbiome, of gut microbiome, of vaginal microbiome. We are coming up with more human gene expression and even mitochondrial disease going forward, right? So we collect this data, right? Which is again an RNA data, which is gives you additional information about various molecules being produced by by various microbiomes. So again, that is the first step, right? Which is again using multi-omics. Second is the cloud computing, where we actually convert using bioinformatics. We convert these molecules and identify which microbe is producing which molecule, which genes they are expressing, how much of being expression is made, and then third step is obviously the mathematics or machine learning, what we call is, right? We convert that into various molecular pathways, right? Since each pathway is linked to a particular biological function, we can correlate these genes expression with your health and disease, right? We could measure these pathways. We can tell you whether a gene is overexpressed, whether you have a disease or not. In fact, we can predict disease. So, build prediction model where we can predict type 2 diabetes, cardiovascular disease, and autism using gut microbiome, right? Even oral microbiome, we could predict cardiovascular disease and type 2 diabetes, right? So now we have this data, And again, this gives a deeper insight about your biology at a molecular level, at a cellular level, which no CGMs or variables would be able to tell you. So, so as I mentioned, if you want to manage your disease, then go ahead with CGMs track and do whatever you want to do, right? That is not going to help you anyways, are going to be sick because you're just managing and suppressing your symptoms. When you suppress, you develop three more, right? And when you suppress those, you develop three more, and this is a vicious cycle. So what we can do is we can give you entire picture or a digital or biochemical twin of your body at a molecular level, what molecules are being produced, how your cells are doing, what genes are being expressed, how your immune system is reacted to it, why you have food intolerance, why your nutrient absorption is low, right? We answer all the questions why. Now we have all those answers, right? Now we match these pathways with so far in our language, we don't consider food as food. We consider food as a sack of 30,000 plus molecules. Now, these 100 million molecular data comprising of 38 trillion microbes, 100,000 genes expressed, 3,000 plus chemical reactions, right, by microbes. So these chemical reactions translate into 50 plus pathways. These pathways talking to 30,000 plus molecules. So essentially, we match this and then provide you right set of recommendations for food supplements unique for your biology. For instance, right, if I have to, for instance, if I have to give you quinoa, certain microbes in quinoa could convert into convert, saccharides into lipopolysaccharide, which is an endotoxin which could cause inflammation, right? Or which could cause even linked to obesity and type 2 diabetes. Or if I have to give you, for instance, spinach is high in iron, vitamin B12, but is also have oxalate. So if your microbes cannot neutralize oxalate, probably spinach would come in our list, right? So these are two things. And another thing we have to understand that, when we talk of antioxidant polyphenols, a lot of these nutritionists will say, okay, probably, or people who usually recommend it that have a lot of polyphenols. So 95% of the polyphenols are metabolized by your microbiome. So we also give you your antioxidant production, right? So essentially you could learn actually how much of antioxidant is being absorbed. Similarly, for B vitamins, vitamin K, vitamin D, right? These are metabolized by the microbiome, right? So these all things would never come up. So your blood work would always say, okay, you have vitamin D deficiency. What should I do? Take supplements, right? But again, your vitamin D or vitamin B12 deficiency has to know the right absorption rate. You need to understand the function of the microbiome, right? Which is missing. So 99% of biology is not addressed by these data points, right? So it is just futile. And even when you call DNA testing, right? Human DNA testing addresses only 1% of your genes. So it's just waste of money.
I've heard is 1% of, actually, it's 1% of the 1%.
Yeah, because I don't know, that's something we could assume or we
I think
could
from a lot
speculate.
of industry experts, we've spoken to somebody, they really have, commented on this, that it is actually the 1% of the 1% of your genes. It
Because
only
they
goes
tell
all
only top 10%.
top,
Yes.
whatever, yeah. So popular ones, more like
Yeah,
that.
so,
Yeah.
so that's the thing, So to sum up, we need these variables and the blood biomarkers are just going to tell you a summary of what has happened inside your body. It cannot go back and understand why it has happened, what has happened, right? You need to understand deep down at your molecular cell level what is happening inside your body. You need to understand, okay, these are the biomarkers, right? These are the pathway which is going to make me develop, for instance, type 2 diabetes, right? If I and our recommendations are focused on suppressing those pathways which is going to cause type 2 diabetes, for instance, and promote which is going to improve your health, right? And again, so another thing what we have added, which is not available right now, and you don't need to have a nutritionist for that. So probably using our platform, you can even plan your meals for every week, You don't need to pay 3,000, 5,000, 5,000 bucks to a nutrition tell, okay, what should I eat in breakfast, lunch,
And
and
then
dinner?
also we have some experiences with people that their diet was tampered by them because they felt that you should eat that whatever was in their avoid list, the nutritionists did tamper with their
Yeah, so,
the
so
recommendations.
that's what I'm telling you what happened is, and that's what prompted us to develop this. That one customer who came who had a skin issue, and he followed our recommendation for some time, and then he thought, I'll talk to a nutrition diet. He told this is, change your diet. This is not the way you should eat, and probably within 2 weeks he had these skin flares coming back and a lot of these things, and then he came back to us. Okay, this is what nutritionist. Well, I told him, this you should never go to a nutritionist. They work in isolation. So I'm not saying they're wrong, but their understanding of nutrition is very limited,
I think it's
right?
very generic. They don't go beyond your carbs, fats, and protein and
For
whatever
instance, for
vitamins.
instance, I'll give you an example. If you are told to eat broccoli, right? Broccoli has antioxidants, right? Broccoli has sulfur which can benefit, but broccoli as
So,
a
I think here
So let me complete it, Robbie. Broccoli, if someone had certain microbes in mouth which can produce hydrogen sulfide, broccoli could cause bad breath,
yes,
right?
yes.
Similarly, it could cause hydrogen sulfide by what microbiome? It could cause IBD, it could cause inflammation in the gut, right?
So that's exactly what I'm trying to point out here is that nutritionist or any human being cannot tell you what molecules are present in the food and how much is required for your unique biology.
And how it
Yeah,
will be metabolized.
exactly, exactly. Without any such data, no nutritionist, no human being on earth can tell you that,
So,
right?
for every listener, please, food is not about protein, carbs, and fats only. There are vitamins, minerals, antioxidants, polyphenol, catechin, right? Sulfurins, oxalate, multiple things, right? Amino acids, So there are different things here, right? Which should be considered. And again, there's a petabytes of microbial data, tens of thousands of biochemical reactions, thousands of tens of thousands of molecules. So, you need to understand how each of the molecules, the food would have 400 molecules, 100 molecules may be beneficial for you, or 300 molecules may be beneficial, one may be bad. So because of that, the food maybe you may be advised to eat less of that. And that all can come through your molecular data, not the CGMs and variables. Right? So there's no point of
Correct.
counting calories on this.
That this talk has been a breakthrough for us because I think we have discussed a lot of things in terms of data, in the name of data, whatever has been happening in the healthcare industry, and I feel this is a bubble,
Hmm.
because the day I'm not sure what kind of investors do fund these companies, what is their vision, but what I feel is that the suffering, the people who are the receivers of this healthcare system is the patients, is the people who are suffering from chronic diseases. And what I need to what I actually feel is that people need to be more educated. They should do their research. It's not only about we are speaking or somebody else is talking or somebody else is saying. I think they should do some research on their own in order to avail any such things in their lifestyle,
Mhm.
right?
Yeah.
So, Sushant, with this we end this talk here. And
Yeah.
any last words would you like to add?
Yeah, so do not, your health is in your hands. As you rightly pointed out, do proper research. And again, do not fall for all the recommendations you have on Google or any nutritions are based on guess or anecdotal evidence in population studies. It may or may not work for you. So you have to understand your unique biology, and you have to understand each. And again, we have now technology in place to actually decode everything going on inside your body, right? So you don't need to again focus. And then for people who are looking to lose weight, it is not about eating high protein diet, and it is not about counting calories. It is about balancing your body. It is about your microbiome.
Thanks, Sushant. That was a pretty awesome talk. And we will be again back with another episode. So keep listening to us. Tune in to Health Discourse with Sushant and Sakshi. We are available on Spotify, Apple Podcasts, Google Podcasts, Amazon Music, and on YouTube as well. Thank you.